So yeah, uh, last time, yo, my goodness. Hmm. Ish. Yeah, last time we dealt with a lot of things, ne? Yeah, we dealt with a lot of things. Dealt with a lot of things, and we were approaching probability, and we dealt with permutation, but it's permutation. It's not permutation. It is permutation. Yeah. I want us to explore more of permutation questions. Still going to explore, but we still, yeah. Okay. Wait. Emails. Hmm. Yeah. So yeah, we. Sorry about that, guys. I'm just preparing the notes on my side. Hmm. Okay. Fine. Oh, grade 11. Ish, I don't want grade 11. Grade 1. Grade 11. Nope. Yes. Aye, man. Oh, yes. This one. Yeah. Yeah, gonna start soon.
Jacob, ewe ngikujona ungakakujona hayi ngihlala ngojeni. Hey guys, ngifuna ukumute la.
Mm. Main action. Okay. Okay. So guys, last time we dealt with probability, Tanker. Last time we dealt with probability, but no, we dealt with arrangement. Sorry about that. But we didn't do probability in detail. So today I want to go into detail when it comes to probability. So uh, now they're saying, let's do this one. Ne? But let me see before. Okay. What? Eh. Uh, okay. I don't understand what is happening here. That is fine. That is fine. I don't. Ish. Hey, can I check something, guys? Ish. I think I'm having two different textbook of same grade 12. I okay. Remember this part. Me to remember. Parktown. I remember. Okay. So before we move, guys, ne? Because I think here what I'm having, I think it's a bit confusing, or am I the one who's confusing myself? I don't understand what's going on here. Arrangement, objects, exercises. Mm. Okay, let's deal with arrangements before we go to probability. Let's deal with arrangements, ne? where letters are repeated. Yeah, before we go to probability. So, guys, here I want us to take a look at this, ne? Where letters are repeated. So, Ghana, when we use the word Parktown, I'm gonna go back to the word Parktown. Do you still remember this word again? Then Garingi, calculate the number of arrangement that can be made by the given word. How many arrangements that can be made by the given word, guys? How can we calculate the number of arrangement that can be made by the given word? What's the answer? Guys, are you still there? People,
Sir, can I see the question?
number of arrangements that can be made by the word Parktown.
Eight factorial.
It's going to be 8 factorial, right? It's going to be 8 factorial. Do you get that? But do you get this? If we use P, we are not allowed to use it again. And get if we use P, we are not allowed to use it again, right? So here, letters are not repeated. Are we together? But what if we calculate the number of arrangements that can be made? And get what if we calculate the number of arrangements that can be made? The same question, the same question, by the way, ne? Wait, sorry. The same question, but this time, what is happening? By the given word, if letters may be repeated. Letters may be repeated. All right. I just want us to look at this in a simple manner. Ne? How many times can we repeat the P, the letter P in the word pattern. Actually, how many spaces are we having here? How many letters are we having there?
8.
We're having 8 letters, right? So we're going to have 1, 2, 3, 4, 5, 6, 7, 8. So how many times can we repeat the letter P? How many times? How many times can we repeat the letter P? Guys, how many times can we repeat the letter P?
8 times.
We can repeat the letter P 8 times, right? So we can have P, 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 we can have P. So we can repeat the letter P 8 times. Anger. We can repeat the letter A 8 times. We can repeat the letter R 8 times. You get what I'm trying to say? So it means that the answer is going to be 8 times 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 8. So it means that if we are calculating for the number of arrangements that can be made by the given word, if the letters may be repeated, it means the answer is going to be what? 8 to the exponent 8. Are we together? Are we fine?
Yes.
So it's gonna be 8 exponent 8. Let's try with this word. Let's try with the word random. Arrangements. If letters cannot be repeated, what's going to be the answer? What's going to be the answer?
6 factorial.
It's going to be 1, 2, 3, 4, 5, 6. So the answer is going to be 6 factorial. What if now we are speaking arrangements where letters can be repeated? What's going to be the answer?
6 to the power of 6.
Yes, it's going to be 6 to the power of 6. Because we can repeat R 6 times, A 6 times, and 6 times. Like we can repeat every letter 6 times. Right? Are we together? So now, we can repeat every letter 6 times. So now I want us to talk about another example. Ne? Let's talk about another example. Let's consider the word dead. And here's the question. How many word arrangements can be made if these words, if the repeated letters are treated as different letters? Let's say these letters are treated as different letters. That's number A. How many word arrangements if each letter like is treated as if repeated letters, sorry, repeated letters are treated as different letters. What's gonna be the answer? What's gonna be the answer?
So is it 3 factorial?
Yes, it's gonna be 3 factorial. Because guys, why am I doing this? I want you to get the difference, ne? There's a slight difference that it is commonly killing people, but those differences we have to learn them in a small scale before we go to the large scale. We have to take it a bit by bit, because if we understand the small scale, there is no way that the large scale can be difficult for you to understand. Langre again. So obvious, last year when we are treating each and every letter as a different letter, again, when we treat every letter as a different letter, it's gonna be easy. Like it's gonna be simply 3 factorial. Because if you notice at the top, the words that we were dealing with, there were different letters. Chemistry, different letters. One tlhalohanya. Number of arrangements, obviously, it's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 factorial can find the arrangements if the letters are not repeated. Because letters, if they are not repeated, obviously. One tlhalohanya. So different letters. So now let's consider this word dead. So now if D and D they are not identical letters, it means that it's gonna simply be 3 factorial. But now here's the tricky part. Let's talk about the tricky part now. Let's talk about the tricky part. Same question. Ne? Same question, by the way. Mara, what's the difference? Repeated letters are treated as identical. Have you ever thought about that?
So is it 2 factorial?
Nope. That's where the new formula comes in now. One
So
line.
the dividing by 2 factorial formula.
Yeah, but I'm gonna break it down to you. One line. So this formula it works like this. The number. Okay, let me put it in a box like this. Ne? Then what are they saying? The number of different ways that n letters can be arranged. Eh, can be arranged on line because of n is when we treat the letters differently. Anger n is when we treat the letters differently. Where m is when we treat the letters as identical. Because if you check, that's when we treat the letters as identical. So what are we going to do? This it is the number is when like we treat it's when we say okay the number of different ways that n letters can be arranged. It means sorry, we are going to treat that as different letters again. Where on the m part is when we do what? On the M part is when we do what? We take obviously. What am I saying? Where M of the letters are identical. Oh, where M of the letters are identical. It means M represents the identical letters and N represents the letters that can be arranged in different ways. So what am I going to do? Where M are identical letters, so now what are we going to say? M of the letters are identical and N, that's where we treat the letters differently. Again. So what are we going to do? Obviously, the formula goes like this, guys. We are going to have N factorial. Obviously, this is the number of the letters. We are having 3 letters and now M letters, we are having identical letters. So now, which letters that are identical? We are going to have D and D. We have 2 letters that are identical again. So we are just going to have what? We are going to have M1. Are we together? So it means what? The number of, like, the ways of the weight arrangement if the repeated letters are treated as different letters. That's where we talk about the n. You're going to say 3 factorial. Mara, when we come to the m part, that's where we talk about the identical letters. We are having 2 identical letters. So now we are going to say what? The answer is going to be 3 factorial times divided by 2 factorial. Am I making sense?
So does the 2 factorial come from D and D?
Yes. It comes from D and D. I will make another example. One good this is. So what's gonna be the answer for this one? What's gonna be the answer for this one? It's gonna be 3 arrangements, right? It's gonna be 3 arrangements. Because of think about it. When we talk about dead, we can have what? We can have dead, ADD, and DDA. These are the only arrangements that we are having. Because of why? These are identical letters. When D is D, D is D. Mara, if D and D they were treated differently, we were going to have 3 factorial only. Does it make sense?
Sir, please repeat it again.
I'm saying that we are only having 3 arrangement if D it is treated as identical because of D and D are the same letter which are identical. You get what I'm trying to say?
No.
Born. D, it is an identical letter. If we let's say we were treating D differently, ne? Let's say we choose the word day. Day. Ish. Day. How many arrangements are we going to have here? 3 factorial, right? So which arrangement we were going to have? Obviously, this is going to be, I think, 6. We were going to have 6 arrangement if D it was treated differently. So we were going to have day. I think it's that or DYA. DYA Y D A Y A D. I don't know what are the other arrangements. It's gonna be A Y D and A D Y. You see that?
Yes, sir.
Mara, check this out, ne? I'm replacing Y with D. I'm replacing Y with D. And get I'm replacing Y with D. Where I see my Y, where I see Y, I put D. 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 Where I see Y and put D. Do you see where we are having 3 arrangements?
Yes, sir.
Because of Y. D is treated as an identical. D is the same letter. D is D. That's why we are having 3 arrangements. Mara, if D it was treated differently, if D and D they were different letters, we were going to say or this we are having 6 arrangements in this letter. Am I still not making sense?
It makes sense, sir.
Hey, others, do you hear me or am I teaching one person here?
It makes sense, sir.
So can you do another example?
Another example.
Yeah, using different letters.
Ish, the point is not ish, you know the point that I'm trying to make here, guys. The point that I'm trying to make here, you should get the difference where we are using different letters and where we are using like where letters they are treated identical. Bon. Let's talk about mom. If the letters they were treated differently, what was going to be the answer of the number of arrangements here?
3 factorial.
It was going to be 3 factorial, right? Like this one, that's where letters are treated as different letters. But let's say letters are identical. Let's say we are having identical letters now. Let's say M is M, where like M is identical. How many different arrangements are we going to have?
Over 2.
It's going to be 3 factorial over the identical letters, which is 2 factorial. Do you see that?
Yes, sir.
Can you see that? Do you get it now?
Oh, sir, so the identical letters are now treated as one.
Yes.
Oh.
So can you use an example where we have 2 or more different identical letters?
Yeah, yes, I'm going there. I'm going there. Hey, I'm seeing chats there. Okay. I'm going there. Okay, now let's say we have the word, I don't know, let me think about it. Ish. Which word, Mar? Belleville or King? The Belleville.
Cotton.
Yeah?
The cotton. Cotton.
Oh, yes. Like this, again.
Yes.
All right. Let me bring the same questions. Let me bring the same questions. How many arrangements if the repeated letters are treated as different letters?
Six factorial.
Yes, because if it was simply going to say 1, 2, 3, 4, 5, 6, so it was going to be 6 factorial. Mar number B, same letters now.
So is it gonna be 6 factorial divided by 2 factorial times 2 factorial?
Yes, basically, because of obviously what is the number of the letters and the factorial of it? Because of the formula, it says n factorial is going to be equals to m1 factorial. It means sorry, it's going to be the repeated letter. You're going to find out, okay, which letter is repeated multiplied by which another letter that is repeated, and external, etc., etc. You get what I'm trying to say? So now is it going to be what? 6 factorial? Ish, let me make sense. Let me do like this, ne? No man, I wanted to treat it as identical. As identical. As identical. So now it's going to be 6. And M1 is going to be how much? We are having how many letters that are repeated? Let's start with O. O, we are having 2, right? So it's going to be 2 factorial multiplied by how many other letters that are repeated? Yeah, 2 factorial. Do you see that? Here, letters are treated as identical. Here, letters are treated as identical. Do you get that? That's the difference. Here, hey, what's going on? With this. You, are we all together, guys? Here,
Yes, sir.
we are having the letters that are treated the same, and on the other hand, we are having the letters that are treated differently. You have to get the difference between the two. So now, let's make another example. Ne? Let's consider the word. Now it's the let's consider the word. Consider the word needed. Let's consider the word needed. Same questions, ne? But I'm gonna put number C. Same questions. How many ways? Same questions. This is number A. This is number B. This is number B. What's gonna be the answer for number A? Simple. Eh?
So question A and B are the same.
Oh, ish. As different letters. As different letters, yeah. What's number A?
Six factorial.
Yes, 6 factorial. And what's number B?
8 factorial divided by 3 factorial times 2 factorial.
Yes, so it's going to be 6 factorial divided by 3 factorial, because of we are having how many letters that are repeated? 1, 2, 3. Times what? We are having D and D, right? D and D times 2 factorial. What's going to be the answer?
60.
Yes, it's going to be 60. Now, interestingly, number C. Now you have to stretch your mind. How many words are made? How many word arrangements that can be made? Ne? How many words arrangement? How many word arrangements that can be made if can be made ish, can be made if the word start with the same letter and end with the same letter. What do you think about this one? Let me allow you to stretch your mind a little bit.
So
Yes?
it's because the only two different letters that are more than like one, it bit treatment. But if say only like letter one ailing like hosna ili diagram also karnali dili it two.
Yeah.
If nearly a one, was it gonna be like 3 factorial times um 3 factorial times 5 factorial? I carry one times 4 factorial because I carry the other one is gonna be at the end. Then you're gonna
Is.
say divided by the 3 factorial because that 3 is,
Mm.
or you don't divide.
Try to rephrase what you are saying. I'm failing to process what you are saying. Ke nyaka go
Say
understand, Oreng?
if not the details and it's a twenty, only e fail, ailing like more than once.
Mm-hmm.
What we gonna say for the first line, for the first designator about 3 factorial times 4 factorial times 2 factorial. Am I making sense?
No, you're not making sense. I'm trying to understand. Like,
Okay.
I get the statement, Mara A factorial. No. Anhlalwayo.
Mm. It is.
Who else who wants to try? Let's try and stretch our minds before I give out the answer. What are you guys thinking? Okay. So, Bon, let us start with the same letter and end with the same letter. And Bon, check this out. We have case number 1. Ne? We have case number 1. We have E. Right? Let's start with the arrangements where this guy starts with E and ends with E. Anger. But I want to talk about the N first. Askera, I told you at the top, or N, when we talk about N, these are number of different ways that N letters can be made. It means we are treating the letters as different. And differently so. So now, let's talk about our N. Anger. We have how many letters on needed? Eh? We have how many letters on needed, guys?
6 letters.
We have 6 letters, I get. It means that we are going to have what? 1, 1, 2, 3, 4, 5, and 6. Are we together? Mara, what's the condition? Yeah? We are treating letters as different letters. Mara, they said, Hore, a letter must start with the same letter and end with the same letter. Mara, the condition number 1, we have E. E is more than 1. So E has the potential of doing what? Of being the first and being the end, because of we have more than 2 E's. We have 2 E's. I get. Am I lying?
So what about D?
No, we're still on case number 1.
Oh,
We're gonna talk about D. Don't worry. But that's a good observation, though. Actually, we have 3 letters, Anger.
Yes, so you have 3.
Yes, we have 3 letters of E, not 2. So let's talk about N. When we treat needed
Mm.
as different letters, but we want to apply the condition in terms of N, what are we going to have?
6 factorial divided by 3 factorial.
I'm talking
6,
about N.
6 factorial. So, heaven. Ring say.
You have born. When you are born. We are treating the letters differently, but there's a condition there. We are treating these letters differently. It means that we have to start with the same letter and end with the same letter. And what spaces are we left with? We are left with 4. And I taught you this. Where one?
So
Yes.
with the way I was okay, with the way I was thinking the first letter, we are going to write 3 because of 3 letters. Then on the last letter, we're gonna write 2 because we only have 2 choices.
We are treating them differently. It's like E is a different letter and E is a different letter.
So
I'm not sure if I'm
it's
making
more like
sense.
we are
Yeah?
acting as if we were told which the first letter is E and the last letter is E. That's where you put
Yes.
1.
Yes. Does it make sense now?
Yes, sir.
It's like me saying, "Oh, okay, sharp, omega. Calculate the number of arrangements if O is the first letter and A is the last letter." What's going to be the answer here?
It's going to be 1 times 3 times 2 times 1 times 1.
Yes, because of 1, 1. And we're going to say 3 times 2 times. Why do you say this? Askiri, these letters are different letters. Do you get it? Do you get it now?
Yes.
Guys, don't forget. Don't wanna end. You guys, you are forgetting the statement. That's why I wrote the statement in red. I said number of different ways that n letters can be arranged. It means to n. It is the letter, irrespective of the repetitive of the letters, we are going to treat them differently when we talk about N. When we talk about M, we are talking about where M of the letters are identical. When we talk about M, we are talking about identical letters. Are we okay? Are we together? Yeah? Okay. Guys, do we understand or we do not understand? So that I can move to case number 2. Should I move to case number 2?
Yes, sir.
Okay. Case number 2. Case 2. D. I'm still on N. How many ways that can we arrange needed if the letter start with D and end with D? Yeah?
Is it 1 times 4 times 3 times 2 times 1 times 1?
Yes, it's gonna be 1 because of obviously the first space is occupied because of we are having what 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The first space is occupied, the last space is occupied by 1 letter, and we are left with 4, 3, 2, 1. Times, 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 and times. Anger. But here is something, ne? Check this out. Let's analyze these cases. Hey guys, do we understand so far? Because of this is not about N. This question is not about N. I want to move to the M part now. Do we understand?
Yes, sir.
Yes.
I want to move to the M part now. But remember the formula, ne? The arrangements, the number of arrangements where we have identical letters, I get, is gonna be what? It's gonna be N divided by M1 times M2 times etc Mn, depending on the number of letters that you are having which are repeated. Are we still together?
Yes, sir.
All right. Now, we were calculating for N. What is our N? As good we had 1, 2, 3, 4, 5, 6. And E did what? Occupied the space. I get. Because of we are talking about N. On N, we are here, guys. On N, we are here. We are treating the letters differently. If E and E, they occupy the first and the last, which letters are we left with?
It's NEDD.
So we are going to be left with N, E, D, D. Anger. Now, let's see now. On this NEDD, which letters that are repeated? Asker, now we are moving to the M. On these letters that are left, which letters that are repeated?
D.
It's D. So what's going to be your answer? Your answer for case 1 is going to be 1 times 4 times 3 times 2 times 1 times 1. We agreed on this one, Anger. Divided by what? Because of the e's are used, these two e's are used, we are only left with one e. One hike. So now we are going to play around these things. Now we are moving to M. How many letters that are repeated? It's D. D is the only letter that is repeated. And it's repeated how many times? 2 times.
Twice.
Does it make sense, Mark?
Yes, sir.
Let's shift to case number 2. We have 1, 2, 3, 4, 5, 6. Which letters that occupies the first and the last on case number 2? Aye, man. Oh, aye, I'm in the right track. Sorry.
It's D and
Which
D.
is going to be D and D. Which letters are we left with? Which
N.
letters is what?
N N E E E.
It's N-E-E-E, right? And remember the formula. Arrangement is equals to what? N factorial divided by M1 factorial times M2 factorial. One M2 factorial times M3, whatever. One. So now our N is equals to what? Is we are going to have 1 times 4 times 3 times 2 times 1 over what? It's gonna be over what? We are now here. It's
3
gonna be over
factorial.
what? It's 3 factorial. Do you get it, guys?
Yes, sir.
Therefore, the final answer for this question is gonna be what? It's gonna be case 1 plus case 2. Or 1. Then obviously this is gonna be 4 factorial and that is gonna be 3 factorial. So we are going to have 4 factorial divided by 2 factorial plus 4 factorial divided by 3 factorial. That's gonna be the final answer.
Oh, so sir, because we're working with like two different letters that have the same, like more than one, that identical, we add them.
Mhm. We add them at the end.
Okay.
Then what's gonna be the final answer? What is 4 factorial divided by 3 factorial? Oh.
I got 16.
Okay. Is it 16? Can I get confirmation?
Yes.
Yes, sir.
Okay. Yebo. Yeah. Let's try another example, guys. Let's try another example. Let's try. Ish. Okay, let's try the word. Let's consider the word night. Ne? I'm just taking you back, ne? How many word arrangements can be with okay, number A. How many word arrangements can be made if the word starts with K and ends with T. What's gonna be the answer there? Don't panic. Don't confuse yourself. Just taking you back, Nji.
It's 1 times 4 times 3 times 2 times 1 times 1.
Yes, because it's gonna be 1, 2, 3, 4, 5, 6. Right? K and T, they're going to occupy that space. That space. And T. And how many spaces are left with? One letter has 4 choices, the other letter has 3 choices, 2 choices, and 1 choice. Times, times, times. Right? And here it's gonna be 1 letter, and here it's gonna be 1 letter. Yes. Wait, 1. Then what's gonna be the answer? It's gonna be 1 times 4 factorial times 1. Right? But let's look at it with the context of arrangements. With this context of ish, I mean, eh, n factorial divided by m factorial. 1 times m 2 factorial dot 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 mn. Let's look at it at the context like that. Let's say the letters are like that. And we want to calculate the number of arrangements. Do we have letters that repeats themselves? Hmm?
No.
Okay, what's gonna be the value of M? Eh? It's gonna be 4 factorial, ne? Which is gonna be 1 times 4 factorial times 1, right? Divide by what? Since we do not have the what do you call this? The number of letters that repeats, it means what is going to be what? It's gonna be 0 factorial. Guys, do you know what is 0 factorial? What do you think is the answer here? When we have 4 factorial divided by 0 factorial.
Victoria.
24.
It's gonna be 24. 0 factorial is 1. Anger.
So can you explain how is it 1 in terms of expansion, or like it's just effect, which is 0 factorial equals to 1?
I can prove it, but I don't want to waste time for the sake of recording. One.
Okay, so
Mara, it's provable. Even though you do it in your calculator, you will see what it's 1.
yeah, I saw it
Mara,
luckily.
mm. So, yeah. Now, Pila Pila, I wanted to write this in this context for the sake of understanding. One. Let's look at other ways. Let's look at winner. Let's look at winner. Actually, let me do this. Let me do this. Because this thing of writing many times. Yeah. Hmm. All right. Let's go to this one. Where is that? Okay. I just want us to go to this exercise here. Hmm. Hmm. Yeah. Oh my goodness. Gosh. Oh, oh. Gosh. Actually, let me just do this. This takes time. Okay. Open this. Paste. and open this. Yeah, let's look at this. Consider the weight winners, ne? What's number A? What's the answer for number A? What's the answer for number A?
Six factorial.
Do you all agree that is 6 factorial,
Seven.
guys? Yeah?
No, say it's seven factorial.
Seven.
Yeah, it's gonna be 7 factorial, right? So basically, winner it's winners, ne? For number A, it's gonna be 7 factorial. And for number B,
6 factorial.
number B.
Yeah.
If repeated letters are treated as identical.
Mm-hmm.
Okay, we have 6 factorial. Anyone else? Or is it 6 factorial? Yes. Or maybe are you commenting down there? I don't see. Yeah?
Oh,
It's gonna be
2 factorial.
oh, you said 7 factorial divided by 2 factorial.
Yes.
Do you all agree?
Yes, sir.
Hey, as good as what we were doing now. Now you are scared. So it's gonna be 7 factorial divided by 2 factorial, which is equals to what? Hmm? Which is equals to what?
2,520.
2,520. Okay.
Yes.
2,520. All right. So now let's look at the number C. Now they're saying how many weight arrangements can be made if the weight starts and end with the same letter. 1 multiplied by 1 multiplied by 1. It's going to be what? 1 multiplied by 1 multiplied by 1. Oh, your mic is very bad, my friend. Yo. Are you using headsets? Yeah? Oratilwe. Yeah, remove the headset. It's gonna be fine. Try and remove the headsets and speak, and you will return them back. Do you hear me?
He sent his response.
He typed.
Yes.
Oh, okay. Okay. What are you guys thinking? He said 1 times 5 times 1. 1 times 5 times 1. What do you guys think?
Yes, because the first letter is going to be N and the last one will be N. Then we'll be left with 5 choices for the first letter for W, and then 4 for I, then 3 for E, 2 for R, and 1 for S.
So basically, number C, what are we going to have? We are going to have, since we are having winners, we are having 1, 2, 3, 4, 5, 6, 7, right? So since we are having 1, 2, 3, 4, 5, 6, 7, we are going to have N and N, right? And since we are going to have 5, 4, 3, 2, 1. So times, right? And this is gonna be 1, this is gonna be 1. And obviously the arrangements, it's gonna be N divided N factorial times M factorial. So what are we going to have? We are going to have 1 times 5 factorial times 1. And on the weights that are remaining, because of we are removing, so we are going to be left with W, I, E, R, S. So in these ways, there are no ways that are repeated. So we can just say 0 factorial. Then that's the correct answer. 1 times 5 times 1. That's the correct answer. So let's check D. Let's check number D. How many word arrangements can be made if, or with this word, if the word starts with W and ends with S? What's gonna be the answer there?
I think it's 1 times 5 factorial times 1 all over 2 factorial.
Okay. Anybody else? People, what's the answer?
Yeah, I agree with the answer.
Or you agree?
Yes.
Let's check it now. Because of we have winners, ne? Winners. Going to have W, we have S. And now what are we going to have? We are going to have inners. Inner. Right? And in this word, we are having a repetitive letters. So the arrangement is equals to n factorial divided by m1 factorial times m2 factorial and etc mn factorial. So now, what are we going to do? We're going to say, okay, on the n, we're going to have 1. This is n, by the way. So here we are going to have what? 1, 1. 5, 4, 3, 2, 1. Times, 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 and times. So now, what are we going to have? We're going to have 1 times 5 factorial times 1 divided by what? By 2 factorial. Then what's going to be the answer? And guys, let's give out the answers ne, for the sake of the recording.
Sixty.
So for this one, it's going to be 50. Ne?
60, sir.
Or 60.
Yes.
Yeah. All right. Let's focus on number 2 now. On the word winning. Yeah. On the word winning. So on the word winning, what are we having? Number 8 is always easy. What's gonna be the answer for number A?
7 factorial.
Yes. We're still having 7 letters even here. Okay.
If I
So
counted correctly.
yeah. 1, 2, 3, 4, 5, 6. Yes. 7 factorial. Number B, which is equals to what?
5,040.
Okay. It's gonna be 5. Number B. What are we having in number B? Yeah. Number B is very interesting. Mara is not that interesting. Now the weights are treated as identical, guys. What's gonna be the answer?
Uh, 7 factorial over 2 factorial. Oh no, 3 factorial times 2 factorial, yeah.
So it's gonna be 7 factorial. Because of we have okay, I and I, it's gonna be 2 factorial and 1, 2, 3n times 3 factorial, which is equals to how much? Which is equals to what?
420.
Yes, it's going to be 420. All right, let's go to number C. Number C, they're saying how many weight arrangements can be made if with this weight if the weight starts with the same letter and end with the same letter. What are we going to do in this case? Hmm? What are we going to do in this case?
So if I recall it correctly, I think it's going to be 5 factorial over 3 factorial plus 5 factorial over 2. No. Ish, I am confused. Sir.
You should work it out. Don't use it like don't just write it down, you'll get it right. We have two options, guys. Ne? We have case number 1, right? So in case number 1, a word can start with what? Askir, we are having winning, right? A word can start with N and end with N. That's case number 1. Then case number 2, a word can start with I and end with I. Do you get that? But let's focus on case number 1. Let's focus in case number 1. So in case number 1, if we are maintaining N and N, which letters are we left with?
It's
But
W I
mhm,
N and G.
I, N, and G, right? So what's going to be N? So we're having 1, 2, 3,
1 times
4, 5, 6. Eh? One times what?
5 for
5 factorial
times 1.
times 1, right? And what's going to be your M? Or let's just do it once. Arrangement is gonna be n. What? Okay. So let's do it once. So arrangement is gonna be how much? It's gonna be n factorial divided by m1 times m2 factorial. So in case number 1, we're having 1 times 5 factorial times 1 over what?
2 factorial.
Over 2 factorial.
Over 2 factorial. That's case number 1. So in case number 2, what are we having in case number 2? We are having the weight starting with I and ending with I. Ne? And now we're having, obviously, it's going to be 5 factorial. So n is going to be equals to 1 times 5 factorial times 1. And what are we going to have? The arrangement. And what are the letters that are left? What are the letters that are left?
It's W. Eh? Yes, I cannot see the word.
You cannot see.
Yeah. Oh, it's WNNNG.
Okay. So what's going to be the arrangement now?
It's going to be 1 times 5 factorial times 1 all over 3 factorial.
Over 3 factorial. So what's going to be the answer?
The final answer is going to be 5 factorial over 2 plus 5 factorial over 3.
Yes. Because if we are looking for the letters, we are looking for a case where they start with the same letter and end with the same letter. Okay. So now, what are we going to do? We are going to have a arrangement is gonna be equals to what? 1 times 5 factorial times 1 over 2 factorial plus 1 times 5 factorial times 1 over 3 factorial. Then you'll get the total answer. What's going to be the total answer?
80.
It's going to be 80. Oh. Yeah. So yeah, guys. For now, like that's it. For now. and I'm gonna upload this on the drive, ne? Maybe if not tomorrow, maybe I don't know it. But if you need a recording, you can just text. Then I'll send you the recording. Even though I didn't upload it, but the recording it's available. Are we together?
Yes, sir.
So yeah, guys. Thank you very much for your patience. So if you have no questions, you can dismiss, ne?
Thank you, sir.
Sharp, sharp,
Thank you, sir.
sharp, sharp. No problem. Thank you.